Hello everyone, I'm Neeti, third year engineering physics student from IIT Roorkee, and today we are going to see the fundamentals of audio and image processing and see how this is related to our ongoing semester course, Applied Instrumentation. So let's begin. So here's a summary of what I'll be covering in next few slides. We'll talk about the fundamentals of audio and image processing, techniques involved in audio and image processing, and what are the various instruments that plays a vital role in them. And next we will talk about how combining the features of audio and speech processing can result in solving a lot of real world problems. So coming to the fundamentals of audio processing is basically manipulation of audio signals to get some desired results. It is used in variety of applications such as telecommunication and variety of medical applications. Some of the voice assistants we all are familiar with, and entertainment, of course. We all come across a lot of content. We watch a lot of content via mobile, laptop, TV, all of which includes a lot of audio processing. So here I've listed some of the key concepts. There are a lot more. I have described sampling, filtering, Fourier transform. And next are the instrument involved. Some most important ones are microphone, amplifiers, equalizers. Also, I'll talk about them in later slides. Now coming to the techniques in audio processing. First one is noise reduction algorithms. So noise reduction is basically removing some unwanted kind of noise from our audio signals. Next is speech recognition. So speech recognition is basically conversion of some sort of audio signals into text or some commands that a computer can understand or transform. And pitch detection is basically identifying the fundamental frequency of a particular signal, which is helpful in later analyzing the signal. And signal compression is reducing the size of a particular signal without affecting its quality, without much affecting its quality. Here also I have shown the noise cancellation this in this figure. With the help of this figure, like as it is shown, this microphone picks up a noise signal, then generates a waveform with 180-degree phase shifted. Then the interference of both of them results in the cancellation of noise. Now coming to speech recognition, I have covered it in an entire different slide out of all the techniques involved in audio processing, because with advancements in artificial intelligence, this technology has given us some of the very beautiful devices such as virtual assistants and audio controlled devices. As I stated, speech recognition is conversion of the audio signals into text or some of the useful commands that can be processed by computer. And here also I have listed instruments involved in speech processing or recognition, such as microphone. So microphone is basically an input device that is used to capture the signals. Next one is audio interface. Audio interface is a device that connects the microphone to the processing unit, and processing unit is a computer or a microprocessor that is used to process the digital signals. So next I've talked about two of the most important instruments used in audio processing. So as I covered, first one is microphone, and it is like the first step in audio processing chain. So it is a kind of transducer that converts the sound waves into electrical signals. An amplifier, as the name suggests, it is used to amplify or increase the strength of electrical signals. Here I also attached an image showing amplifier. So coming to the second part of our presentation, which is image processing. Image processing is manipulation of images using algorithms and different computational techniques. It can be used in variety of applications such as medical imaging, X-rays and CT scans, in GIS systems and biometric sensors. And image processing combined with artificial intelligence can do a lot in today's world. Here are some key steps involved, like capturing image, pre-processing, enhancement of the image, its restoration, feature extraction, then its comparison, and finally analyzing and interpreting it. Coming to the instruments involved, first and most important one is camera, which everyone is familiar with. So they capture visual data in form of images and videos. Next is MRI machines. So MRI stands for magnetic resonance imaging. It contains RF coils, radio frequency coils. When the RF pulses are turned on, they generate the radio frequency waves, and these waves are absorbed by the hydrogen atoms within our body tissues. So the hydrogen atoms get excited by absorbing these radiation, and later when these pulses are turned off, they emit energy in form of EM waves, which can later be used for this body imaging. Here are some other instruments common for both technologies, which we have also seen in our lab experiments. First one is analog to digital converter, EDCs. Uh, as the name suggests, it converts the analog signal to digital signals, which can further be processed by microprocessors or the computers. Next is digital signal processors, DSPs. So these are specially designed for handling the digital signals. And in audio processing, they are used for filtering, equalization, and other audio effects processing. And in image processing, they are used for image enhancement, compression, as I've talked about them in earlier slides, and some of feature extractions. So coming to the last part of our presentation, which is integration of audio and image processing. So, combining audio and image processing can be used in various advanced technologies, such as emotion recognition. So, for example, in a video, the facial expressions can be identified through image processing, and the tone or voice can be detected by audio processing. So, by combining both of these, we can like find out what a particular facial expression demonstrate, what emotion a facial expression demonstrate, and it can be used in human computer interaction. Next one is visual speech recognition. This technique can be very helpful for people having hearing issues. So we can recognize the spoken words by analyzing the lip movements and the corresponding audio signals. That's all for my presentation. Thank you so much for watching.